Students, in the last video we have seen 9 problems in complex integration. So we will continue that. Now this is 10th problem in complex integration. Evaluate integral over C 3z minus 1 by z cube minus z into dz, where C is a circle. Two subdivisions are given. The first one mod z equal to 1 by 2. The second subdivision mod z equal to 2. Now the given integrand can also be written as z is common, so z square minus 1. Again you can simplify this. Z square minus 1 can be written as z minus 1 into z plus 1. Okay. Now see the first subdivision. The circle is given as mod z equal to 1 by 2. So you draw one rough circle for this. Center is origin, radius is 1 by 2. Origin, radius is 1 by 2. Okay. I by 2, this is minus I by 2. Now see here, this z can also be written as z minus 0. Okay. Now three factors are there here. The first factor is z naught is 0. The second factor is z naught is 1. The third factor is z naught is minus 1. So which lies inside the given circle for the first subdivision? Only 0 lies inside the circle. And 1 and minus 1 lies outside the circle. Which means what? You have to write this z in the denominator. You have to take other two factors to the numerator. Okay. So 3z minus 1 by. So I am writing this form. All are same. All the three are same. I am writing z. Z can be written as z minus 0. Since 0 lies inside the circle, I am taking z square minus 1 to numerator. Now you can denote numerator as f of z, z naught as 0 into dz, where f of z equal to 3z minus 1 by z square minus 1, z naught equal to 0. Now using Cauchy integral formula, the formula for this one is 2 pi I into f of z naught. So 2 pi I into f of z naught is 0. And what is f of 0? You substitute here. In place of z you substitute 0. When you substitute 0, you will get 0 minus 1 by 0 minus 1. Minus 1 get cancelled, which is equal to 2 pi I. So this completes the first subdivision. So now second subdivision, the circle is what? Mod z equal to 2. Okay, you draw one rough circle here. You say this is 1, this one is 2. You say this is I, 2i. You say this is minus 1, minus 2. And say this is minus I, minus 2i. Okay. Now for this circle, mod z equal to 2, 0, 1, minus 1, all lies inside the given circle, isn't it? All the three z naught lies inside the given circle. If more than 1 is z naught, lies inside the given circle, how to solve this type of problem means, you have to take this fraction separately, resolve into partial fraction, then use Cauchy integral formula for each and every integrand. So I am taking this fraction separately now. 3z minus 1 by z into z minus 1 into z plus 1. Resolve into partial fraction. This you know that a by z, b by z minus 1, c by z plus 1. Now LCM is a into z minus 1 into z plus 1, b z into z plus 1, c z into z minus 1. to find the value of ABC, you put z equal to 0. So 0 minus 1 is minus 1. When you put 0 here, minus 1 plus 1, other two terms are 0. So minus 1 is equal to minus a, so a equal to 1. So next put z equal to 1 for this factor. When you put 1 here, 3 minus 1, the first term is 0. B into 1 plus 1 is 2, C is 0. So 2 equal to 2b, so from this b equal to 1. So next you put z equal to 2, 3 into 2, 6 minus 1, the first two terms are 0, C into 2 minus 1 is 1. So this is 5 equal to 2c. Sorry, not 2. You have to put z equal to minus 1. Isn't it? You have to put z equal to minus 1. So when you put z equal to minus 1, this will become minus 3 minus 1. The first two terms are 0. C into minus 1 minus 1 minus 1 is minus 2. So this is minus 4 equal to minus or minus plus 2c, or c equal to minus 2. Now substitute all these three values in this fraction. A is 1 by z, b is also 1, and c is minus 2. Now integrate with respect to z on both sides. And this factor can also be written as z cube minus z. You apply integral dz on both sides. Z can also be written as z minus 0. Sorry, this is plus 1. Minus 2 integral dz by z plus 1 over c. So if more than one z naught lies inside the given circle, you have to take that fraction separately, resolve into partial fraction, find the value of ABC like this. Now integrate on both sides. Now you have to apply Cauchy integral formula for each and every integrand. So this is a way to solve if more than 2 z naught lies inside the given circle. I'll write straight away here using Cauchy integral formula. How to write this? 2 pi I into f of z naught. Z naught is what? 0. Similarly for the second integrand, 2 pi I into f of z naught is 1. Minus 2 into 2 pi I into f of z naught is minus 1. Where f of z equal to 1 in all the three integrands. You see the numerator. The numerator is f of z equal to 1, and z naught is 0, z naught is 1, z naught is minus 1. Now f of z equal to 1. F of z equal to 1. So f of 0 is 1. F of 1 is 1. F of minus 1 is also equal to 1. Since this is constant. If this is constant, if you put z equal to any value, that constant remains the same. So substitute here. 2 pi I into 1 plus 2 pi I into 1. This minus 2 into 2 is minus 4 pi I. F of minus 1 is also 1. So 2 plus 2, 4 pi I minus 4 pi I, which is equal to 0. So this completes the second solution.